Right, so the problem is going to be remove nth node from end of list. We're going to be given the head of a linked list and an integer n, and we have to remove the nth node from the end of the list and return its head. So if you have 1, 2, 3, 4, and we have n is equal to 2, we want to remove the second element from the back, right? We want to get rid of this, basically. But of course, it's not an array, it's actually a list. So it's going to be like this. And we have to get rid of this. So in the linked list world, when you want to get rid of an element, all you do is sever the connection between this and the rest of the list, right? So if I redirect this arrow, instead of pointing it here, I have it point to 4 instead, then effectively, if this is our head, the flow would be 1, 2, and 4, completely missing out 3, right? So that is what we mean by deletion. And what if there's only one element? In here, we have a single node 5 and n is equal to 1. And of course, 5 is pointing to none, right? Because this is just one node. So removing this, well, it's a little bit awkward because there's no elements that come before it. So if I were to use the same algorithm as this, well, let's say if this is current and this is previous, running this would probably mean that prev.next is equal to prev.next.next, right? So this arrow, we're going to redirect that to prev.next next. But you can't really do this here because we don't have a node here to run this on. And for that, probably the easiest thing to do is just like in some other linked list problems, we have a dummy node. Dummy node usually has a default value of 0, and we'll initialize this to be pointing at our head initially. And then what we can do is set this as our previous, and we can run the same line. So this arrow would be pointing to what this guy is pointing, which is none. And then at the end, we can see that head is equal to the dummy here dot next, right? In the case where we remove the head, this will give us none. And in the case where we don't remove the head, then well, the head doesn't change at all. Oh, and since we're here, we might as well cover the case where we try to remove an element at the very end. So let's say this is our input and we want to remove n equals 1. Like we want to remove this thing, right? So our previous would be here, and then our current pointer is probably pointing at this thing. Would the same code still work? Where we're going to point prev.next to prev.next.next? Well, let's take a look. This gets redirected to none, right? Effectively removing this thing. And yeah, it still works. We can still run the same thing. So that's how we're going to be handling the removal. But we also have other issues, right? Like, how are we supposed to know which node we want to remove? Because if it's an array like this, and we want to remove n equals 2, we know that the second last element is the same thing as index -2, right? Or I guess generally it's -n. So here it's 2, this is -1, this is -2. That's really easy in an array. We can just access that. But in the linked list, it's not so simple. The more straightforward approach is to run through this list once to calculate the length, right? Because, you know, we don't know the length of a linked list. So we have a pointer, it just runs through and it keeps a counter, right? And when it arrives at none here, well, our length should be 4 because it's moved 4 times, right? From here, 1, 2, 3, 4. Let me change the example a bit. Now that we know the length, and we have the n, and we know this is the element that we want, right? We want to move our pointer 1, 2, 3 times from the starting position. In other words, we want to move length minus n times to get to the destination that we want to remove. So we start again with a pointer, it moves once, moves twice, moves thrice, and then it arrives here. Then this is the node that we want to remove. And we can just run the removal algorithm as per discussion earlier. But what if we don't want to do 2 passes? What if we just want to do it in a single pass? That's actually also possible. And how we're going to do that is by having 2 pointers, a left and a right pointer, everyone's favorite, right? Oh, and of course, I forgot to mention, but we still have our dummy node here in the beginning to make it possible for us to remove the head node. Right, so 1 pass. How are we going to do this in 1 pass? So I think the easiest way to explain this is if you imagine if I have a pointer, let's say this is none, right? Let's say I have a pointer that points to our target, and then I have a second pointer that points to the end of the list. Now, if I move all of these elements to the front, so if you notice they are 2 spaces apart, right? Like let's say I move them 1 by 1 and so on and so forth. I'm just going to fast forward. So you know they're 2 nodes apart, and we can initialize our left pointer here and our right pointer here. And our right pointer is going to be n spaces away from left. And if we just move both of these like 1 spot to the right every single time until right ends up here, then we can also see that our left is at the node where we want to remove the thing. And that means we've identified it in one pass. We don't even need 2 passes with this algorithm. If you remember, the removal code is basically this, right? So we need a prev here, but I think it's easier if I make left and right n+1 spaces apart. So if I do that, then left would end up here, and then we can say left.next, this line, this arrow is gonna be left.next.next. So this arrow is gonna be pointing here. Then our full list is gonna be dummy 1, 2, 3, 5, right? So let's create our dummy node. We point the dummy to the head. So left and right are gonna start at the dummy node. So you know that we want left and right to be n+1 nodes apart. So we want our right to move, well, n+1 nodes, right? So for underscore in range n+1, right? Right is equal to right.next. And then now, after this, we are basically in the situation where we have a dummy 1, 2, 3, 4. Our left is going to be here. Yep, our left's going to be here. And then right is going to be n+1 units apart. So 1, 2, 3. R is going to be here. All right, so that's nice and initialized. Our next job is to keep moving until R reaches none, right? So let's just write a while loop. While right is not none, I'm just gonna increment left and right by 1. So move them one at a time, one at a time, one at a time. And in total, this is gonna move twice. So our right pointer is gonna be here. L is also gonna move twice. So our left pointer is 1, 2, over here. And you know, this is the node that we wanna remove. 1 node after L, this 3 here. So for the removal, we just do left.next equals to left.next.next. And remember to cover the case where we are removing the very first element. I'm going to say that head is equal to dummy.next, right? Just as a refresher, if I'm removing the first element, then it'll look something like this, right? At n equals 1. We're serving this connection here, and this is where our head normally is. So after we chop this off, we want to say that head is here at dummy.next. And then we just return head. Get rid of this. And let's run it. Time complexity, we just have 2 pointers and then we're looping through the entire array. So it's linear time. Now that I think about it, every element gets processed twice anyways with this method. So I don't think it's that much better than the original 2 passes that we did. Yeah, I mean, the left pointer is processing every element n times, and same for the right pointer. So it kind of works out to O of 2n. Likewise with the 2 passes, well, we just have a pointer and it goes through the list twice. So I think it's kind of the same. All right, but this is the canonical solution, if you will. All right, thanks for watching. Okay, bye.